All right, everybody, this is section 5.5 on solving right triangles. The first half of chapter 5, we talked a lot about SOHCAHTOA and the trig ratios, those comparisons between two sides. So we're still going to be using that, Pythagorean theorem, all of that. But now in this part, or this section, we're going to be looking at how you solve for the angle measurements. We didn't actually ever talk about how would you figure out a value of the angle if you know the ratio of sides. So we're going to kind of work backwards and use inverse operations to do that. So that's kind of our next piece. So if you have trig functions at a given angle, you can also find the angle measurement by using what we call the opposite operation. So we can find the measure of the angle using the inverse. So what I have written up here are the functions using our universal symbol theta for our angle measurements and just equal to a. A is standing for just a number. So remember, when you write the ratio of two sides, opposite over adjacent, you can write it as a fraction, or you can write it as a decimal. So we're just thinking of these a values as they're standing for whatever number that's equal to. If you want to solve for the angle measurement, then what we do is the opposite operation. We need to undo sine to figure out what theta is. We need to get rid of that. So when we write that out, I'm just going to show the work down here for the first one. What we do is we do the inverse, or the opposite operation, on each side. Just like if you were going to get rid of adding, you subtract on both sides, or to get rid of multiply, you divide. What we do is we do the inverse, and I'll show you a couple different notations for that, on each side. So that -1 is standing for inverse. If you remember way back in chapter 1, we found inverses, or actually maybe it was chapter 3, we switched the x and y, solve for y, doing that process, that inverse idea. The function notation inverse is this little -1 symbol. It's not an exponent, it means opposite operation. So what happens when you do the inverse on both sides? Well, if you take a function and then do its inverse, what you're left with is the input. So think of it this way: pick a number, any number you want, multiply it by 5, then divide by 5. You get back to the number you started with, right? And that's exactly what inverses do. So over here we'd be left with theta, and on the other side this is read the inverse sine of a. So our inverse relation, theta, would be equal to the inverse sine of whatever a is. And by the same measure you can do inverse cosine and inverse tangent. So when you read this TAN with the little -1, or COS with the -1, that's read inverse of sine, cosine, or tangent. So when you're saying it, inverse of sine, inverse of cosine. So it's the opposite operation. Now there are other words that people use to describe these, and I want to talk about that too. Some of the words that you might see besides that are also, there we go, it's moving down kind of slow. The other words that you might see are arc sine, arc cosine, and arc tangent. Those are also inverse relationships. So instead of writing theta equals inverse sine like this, you could also write the arc sine of a, and that would mean inverse as well. So if you want to fill that in with your table, then another way to write it is arc sine of a, arc cosine of a, and arc tangent of a. So arc, that prefix ARC, means the same thing as inverse, so opposite operation. So on your graphing calculator, take a look above your sine, cosine, and tangent keys. That's inverse sine, inverse cosine, inverse tangent. So those little right above here, so inverse sine, inverse cosine, inverse tangent. So those are the buttons we're going to be using then when we're solving for our inverses. Okay, so let's take a look at some examples that we might be able to do to illustrate this. Let's start with the idea of what does inverse mean. So they're saying evaluate these expressions, assume that you're in quadrant 1, meaning everything is positive. I'm going to go ahead and draw a triangle to talk about what this situation is saying. So reference angle in quadrant 1 here. So my theta is this guy right here. If they're giving me the arc cosine, inverse cosine, what that means is the cosine ratio is 2/5. So remember in SOHCAHTOA what cosine is. It's adjacent over hypotenuse. That would mean this is 2, and that's 5. Now I could find the third side of the triangle if I wanted to, right? I could figure out what that y value is, the opposite side, if I needed it, and I could find any trig ratio I wanted. Well, what trig ratio do they want? Well, they want the cosine. Well, the cosine ratio in that triangle would be 2/5. So let's see if this makes sense to you then. If you take the cosine of the inverse cosine, these would cancel each other out. They undo each other, just like times by 5, divide by 5, and you're going to be left with what's inside. So they're inverse operations, but there's still a triangle that's associated with that. So if I give you an inverse, you still know two sides of a triangle. Okay, so let's see if that works for this one, because these aren't inverses. Take a look. They're not inverses of one another. So they don't just undo each other. I need to be able to draw the triangle. All right, so in quadrant 1, so my reference angle in quadrant 1, inverse sine, arc sine, that means opposite over hypotenuse. So the side that's opposite is 5, the hypotenuse is 6, you want cosine. Well, to be able to do that, I'm going to have to solve and find that third side of the triangle, so I need to find my x. So just do the Pythagorean theorem and solve. So we get 36 and 25, so it looks like x squared would be 11. And since we're in quadrant 1, I don't have to worry about plus or minus. It would just be positive square root of 11. Okay, well now I have enough information then to be able to find any ratio that they asked me for, but what do they want? They want cosine of the angle represented by that statement. So cosine of this triangle that we just drew, and cosine would be square root of 11 over 6. So remember, if you know a ratio, that means you know two sides to a triangle. We can find the third side and we can find everything we need. So inverse gives us that same information. Okay, well the other things that we're going to be doing is doing something called solving a triangle, being able to find the missing pieces. So when you see the word solve, it means find all the pieces that you don't know, sides, angles, whatever it might be. So I'm going to go ahead and put in the information that I have. So for here, angle D is 48 degrees. And side E is 25. So for this triangle, let's take a look and see the pieces I don't know. I don't know little d, I don't know little c, and I don't know angle E. So let's talk about how we could find those. Is there a pretty easy way to find angle E? Well, these other two angles in a right triangle have to add up to what? If the whole triangle is 180 and you know there's a 90 in the corner, that means these other two would have to add up to 90. So I can find angle E pretty easily, just subtracting 48 from 90. So angle E is 42 degrees. So that one's not so bad. So angle E, 42 degrees. All right, well, we can use SOHCAHTOA to find the other sides because it's a right triangle. So we can go ahead and set up. There's lots of different ways to do this. Remember, you just have to know which angle you're using. So say we want to use angle D, the one that's given. Usually a good idea. It's never rounded. We know it's an exact number. Say we want to find side D when we know E is 25. So we want the opposite. We know the adjacent, so that would be tangent. So the tangent of 48 degrees is equal to d over 25. So really nothing new from what we're talking about right now, other than they're having us find all the pieces with angles included. We never did angles before. So if they give you one of the angles, pretty easy to find the other one in a right triangle. So multiply by 25, we get 27.8. So we have little d. Okay, let's talk about how we can figure out side C then. You could use Pythagorean theorem, because you know two sides, but this 27.8 is rounded, so it might be better to do a trig ratio to find it, because then we can use given information and we don't have to worry about the rounded answer. So let's try to do that. So with this 48 degrees, I know the adjacent side. I want the hypotenuse. So what ratio is adjacent over hypotenuse? That would be cosine. 25 over c. And remember, when you're doing it that way, when you type it in, it would be 25 divided by cosine of 48. So that means side C, go ahead and do the divide, would be 37.4. So we can solve and find all the pieces that we don't know. So in this one, finding the angle wasn't too tricky because we already had one of the angles, and we can find the other sides using trig ratios. Okay, what if you do if you don't know any of the angles? So let's take a look. So side Q here, we'll put in our information is 38, and R is 22, and they want you to find S. Well, there's S. I found it. Yay! Just kidding. They actually want us to find the angle measurement for S, not just where is it on the picture. Okay, so let's take a look and what do you know about the triangle in relationship to angle S? Well, you know the side that's adjacent. You know the side that's the hypotenuse. So which trig ratio uses adjacent and hypotenuse? Well, that's cosine. So the cosine of angle S is equal to 22 over 38. So that's the relationship. That's the ratio. Now, that's what cosine is. Well, I just want the angle measurement, so I need to undo cosine. Cosine is a function, it's an operation, so I'm going to use its inverse to get cosine by, or to get S by itself. So I'm going to do the inverse cosine on each side. Now, it's not very often that I'm going to show the work for this, because after you do it about 1,000 times, you realize, gosh, the same thing always happens. But cosine of the inverse cosine, they undo each other. What you're left with is S. Just like times a number by 3 and then divide it by 3, you're right back to the number. So what you're going to type on your calculator is the inverse cosine of 22 over 38. So for this first one, let me show you on the calculator what that means. Double check your mode, make sure you're in degrees. All right, so we type in inverse, so second cosine, and then just your fraction, so 22 divided by 38. And enter, and we get 54 point, and we're going to round to tenths, I think, so 54.6 degrees. So angle S is equal to 54.6 degrees. Now think about it. Could you find angle R then if you knew angle S? They didn't ask you for it, but how could you do that? Well, these two angles, S and R, would have to add up to 90 degrees. So you would do 90 minus 54.6. You'd have angle R. And I bet you could find angle S. We could do that to, or side S, because now we have two sides. We have an angle. We could set up a trig ratio to find that as well. Lots of different ways to do that. So we're looking for ways to solve and find the missing pieces. So if we don't have an angle, we want to be able to find it by using our inverse. Okay, let's try another one. So solve the triangle. What that means is they want you to find everything. All right, so side C is 65. Side D is 47. So I don't know either angle E or D, and I don't know little e either. All right, so you just have to decide which way we want to start here, which one we're going to try to solve for first. So that's just kind of a decision to decide which one makes the most sense here for what we're going to solve. So let's take a look. Maybe we'll find this third side of the triangle here. We can find side E with those two pieces. So we have the Pythagorean theorem. So 65 squared equals 47 squared plus E squared. Your other option is you could find an angle measurement first and then do a trig ratio, and that would be fine too. So go ahead, pause the video, go ahead and solve for E. And we're going to round these and just take the square root. So we're not going to worry about simplifying the radical since everything else is in decimal form. It's fine to leave a decimal. So go ahead, pause the video and solve. And I ended up getting 44.9. for my side E, so I know what that is. I'm going to really try to avoid using that number now, though, to find the angles, because I don't want to use a rounded value if I don't have to. Okay, so let's take a look. It doesn't really matter. I'll say I'll find E. All right, so angle E, the two sides I know compared to angle E are this one and that one. So the one on the bottom, this side D, the 47, that's adjacent. This one's hypotenuse to this angle E, so I'm going to use those two sides. That would be cosine. So the cosine of angle E would be 47 over 65. And again, I don't want cosine of 47. I want just E. So I need to undo that, do the inverse. Now you could write R cosine of cosine. When I show my work on these, I usually use this inverse notation. I just think it's faster. So that's what I'm doing on each side. Remember, equalities, we're doing the same operation on both sides. That leaves E, and over here we do inverse of 47 over 65. So go ahead and type that in, see what you get. So pause and type it in. I came up with 43.7. So double check your work there, make sure you're good. So this angle is 43.7 degrees. Okay, now to find your other angle, the last thing, the angle D, do you have to use a trig ratio? Well, you sure could, right? Because we could set it up. We could do sine and do for angle E. So we could do tangent. We could do any of those, really, right? Because we know all the sides. If we wanted to use unrounded things, I would do sine of angle D equals 47 over 65, and you could solve. But since I already know one of the angles, all I have to do is just subtract from 90. That's the quickest way. But it's not wrong to do a trig ratio. You're going to get the same answer either way. So we end up with 46.3 degrees. So we have solved the triangle. We found all the missing pieces. Okay, so we really look for those different values. Okay, so let's take it a step further here then so we can do some applications. Basically what we're looking for is being able to describe that in a real life setting, being able to find angle measurements too, not just side lengths, by being able to draw a picture and use SOHCAHTOA. So we have a ladder leaning up against a wall. So here's my wall, here's the floor. I have a ladder leaning up against the wall. So my right angle, hopefully, is between the floor and the wall. So the wall is over here. And this is the ladder. Okay. Now, in my picture, it says that for safety reasons, the 30-foot ladder should be a quarter of the distance away from the base of the wall. So however long the ladder is, you only want it to be a quarter of the length of that ladder away. So if the ladder is 30 feet, that means the distance down here, they only want to be a quarter of 30 feet. So I need to figure that out first. So what is a quarter of that 30 feet? Looks like that would be 7.5. So the bottom would be 7.5. What they're trying to have you figure out then is for that safety guideline, what would the angle measurement be between the ladder and the ground. So down here, this theta, what angle measurement should you have that ladder? So when you're kind of leaning it up against the wall, when you're eyeballing that, what should it be? Well, let's see what we know. We know the adjacent side. We know the hypotenuse, which is the length of the ladder. So adjacent over hypotenuse, that would be cosine. So the cosine of theta is equal to 7.5 over 30, or it's a fourth, right? Because that's what we just figured out over there. And again, I don't want what the ratio is. I actually want the angle. So I'm going to do inverse cosine on each side. And again, I know you kind of get sick of writing it on both sides. What some people will do is they'll do this. Instead of writing the green statement, what they'll do is go straight to what I'm writing in red. They'll just say theta equals the inverse cosine of 7.5 over 30. So if you want to write it that way from the blue to the red, I totally understand what you're doing. And then we need to calculate what angle would that be. So when we do our calculation, it would be about 76 degrees. So somewhere in that range is the safest way to be able to lean a ladder up against the wall. So we're just, again, looking to draw a right triangle so we can use SOHCAHTOA. But now today we're even finding angle measurements as well. Okay, let's take a look at this one. See if you can draw the picture. So it says a group of hikers wants to walk from, I think that's supposed to say from, a lake to an unusual rock formation that they want to take a look at. So they're going to go for a hike. The formation is 1 mile east and 0.75 miles north of where the lake is. All right, so let's make a picture here. So we have a lake. All right, so we have the water. This kind of looks like a potato, but there we go. And then we go 1 mile east. So think of your directions here. So north is straight up, so 1 mile east. And then 0.75 miles north. So turning and going straight north from there, 0.75 miles that way. So my right angle is actually there. All right, so we have an unusual rock formation. So there's a bunch of rocks standing up there. All right, what angle direction should they hike to go straight from the lake over to the rock formation? So starting here, measuring to that rock formation, what measurement would that be? That's what they're talking about. So we can create a right triangle out of this to do that measurement. All right, well, let's see what we know. We know the side that's opposite. We know the adjacent, so that would be tangent. So the tangent of theta would be 0.75 divided by 1. So how do I undo tangent? Well, I do its inverse on each side. So if you're okay, I'm going to go ahead and just write it like this. It would be the inverse tangent of 0.75 divided by 1, which is the same thing as saying just 0.75. And that would be about 37 degrees. I'm rounding off there a little bit, so 37 degrees. Now, that's the measurement of this angle. When you get into physics, you talk about direction. So technically, for those of you that might be in physics, they would say that that is north of east. Because if this is east, and this direction up here is north, you are measuring 37 degrees north of east to get to that location. If you just say 37, I got you, but that's what that would be officially. So those hikers leaving from the lake should set their compass for 37 degrees north of east. So they know where they're headed. So being able to solve for the angle measurements in a triangle is also important. We don't just focus on our side lengths. We still use our SOHCAHTOA, though, to be able to solve for those missing pieces. So our assignment that we're going to be working on will be finding angle measurements and side lengths. So SOHCAHTOA, but with angles, section 5.5.